Welcome back, my fellow game developers. In this video we are taking our game to the next level. When we run our game, you'll notice that not only we walk around, but if we try to leave our map, there we go, we cannot. I swear I'm still pressing the A key, I'm still trying to go down, but it doesn't work. I'm still trying to go out, it doesn't work. So we are confined in this little space. We do that using rigid bodies, using colliders, and this is really nice because finally we can feel the weight of our game. So even though we could walk, we could see, we can do anything, but now we actually have weight to our movement. We can feel the world around us. With that said, let's not waste any more time and let's get started. Okay, so currently when we run our game, we can move and all, that's great, but as you can see, when we try to hit the wall or something, we just move past it and it's as if there is nothing in this world. It feels empty, it feels not real, even though we are moving in it. So how are we going to fix that? We are going to use something called a collider. Let me show you what a collider is in the Unity documentations. As you can see, always refer to the Unity documentations. You can get there through Google. It's super easy, super effective. Let's see what we have. Description: base class of colliders. We have box, sphere, capsule, a mesh collider, physical materials and rigid bodies, something that we will learn in just a bit. If an object with a collider needs to be moved during gameplay, you can attach a rigid body component, and we'll just get in a rigid body. A bit of patience. You can see all the properties that we can have: the bounce, the contact offset, the material. We have public methods such as raycast, closest point. We have messages, which are extremely important and we'll be using a lot of on trigger enter, on trigger exit, on trigger stay. You can read the descriptions right here of what each method, what each property, what each message means, what it does. All the inheritance, what we can use, the compare tag will be very important. You can see that we have a lot. You don't have to understand every single one of them. It's just nice to know that you can, if you have something in mind to implement, you can always go into the Unity documentations and see if what you're looking for is available right here. So with that said, let's go back in here and let's go ahead and add a box collider to one of these walls right here. Let's start with the bottom one. So the way we do this is we are going to right click in here, or let's go to the background. Let's add a component in here. We're going to make it a box collider 2D because we are working in 2D. This box collider is 3D. This one is 2D. We click on it. You can see that it fills the entire room immediately, but we don't want that. We actually want to edit this, so we can click on the edit right here. You can see we can make it a trigger, we can set an offset, we can set the size, so we can make this smaller on the y-axis, or we can simply click on these three connected dots right here and just move it manually. So there you go. So now we have this collider right here on the wall, or the bottom wall, whatever you want to call it. We can unclick this, we can run the game, and now our player, when he moves down, oh well, what's happening? The player is still hitting this wall and he is moving past it. Why is that? Well, because we don't have a collider on our player. So this is going to be your challenge, and your challenge is to add a collider to the player. So add a collider, a capsule. It doesn't have to be a capsule, it depends on the size and the frame of your player, the one that you personally got, or if you're using the same one as I am. Make sure it's on the player parent object, not the body. And change the size of the collider to the appropriate size of your player. So with these instructions, pause the video right now and go do the challenge. Okay, welcome back. So how did you get on with that? We are going to add a capsule collider 2D. There we go. We have the capsule. I'm not even sure how it's pronounced. So we click on here. You can see the little green line in here. So we are going to take it down. There we go. And make it just about the size of our player. Now, let's see if that works. If we run our game. Now when we go down, whoop, we are still moving through the object. Why is it not working? I should have probably warned you about this. Now we are going to add a rigid body 2D. And now when we run the game, we shall see that we hit the wall, but I didn't press anything. If I move up and let go, we fall down. Why is that? What is happening? Well, because when you add a rigid body, you also add gravity. Let's delve a little bit deeper into what a rigid body is. So, it's control of an object's position through physics simulation. So when you add a rigid body to a game object, you add physics to it. Rigid body object will be pulled downwards by gravity without adding any additional code. And we can also apply our own forces to them, which I mean by them, it's the rigid body. You can also go into Unity's documentations and delve deeper into what rigid body is. And in fact, we are going to need to delve into it. So I'm going to go in here, rigid body, Unity docs. There we go. There we go. We see the docs Unity 3D. And you can see the description, the properties, the public methods, and so on and so forth. So let's go back in our game. We can see right here we can change the mass, the angular drag. We can change the way the collision is detected, discrete, continuous, but it takes a bit more processing power. The sleep mode, the constraints, we're actually going to use them in just a bit. You'll see why. And we can change this from dynamic to kinematic to static, and each one of those are explained right here. But the main difference, where is it explained? Somewhere in here, I'm not sure where. You can read about each one to delve deeper into it, but know that dynamic means we can affect it by outside forces, kinematic means it doesn't get affected, and static means it's just like a big rock. It doesn't move at all. We can see right here the gravity scale. Let's set it to 0, save that, run the game, and now you'll notice that we do not fall anymore. So now when we go down, you can see that we can no longer go under this, but what happened? And you can see that we move around. We need to add a box collider. But what happened in here, and what's all this jittering? So first thing we'll fix is the flipping things. So this is because we are rotating. You can see right here, it's actually because the physics has calculated that we should rotate because of the capsule right here. So we'll freeze the rotation around the z-axis. Why the z? Because, let me show you, if we click on the rotate tool up here, or simply hit the E key, we can see when we rotate, it's the z-axis that rotates us. And we can clearly see it when we go out from 2D. You can click on this 2D right here. We go out. You'll notice that the z-axis, you can see it, there we go. It's around the z-axis that we are rotating. So we'll stop the 2D. We'll set this to 0, we'll freeze on the Z, and now when we run our game, we go down, and there we go, we no longer flip if we move from left to right, but we still have this jittering. And what is this jittering? Where is it coming from? Well, it's a matter of code. We can see right here that we are moving the player using his transform.position. So we have two colliding forces. We have the transform.position trying to go through this wall, but we have the physics from the both colliders trying to push the player away. So this is creating this jittering. How do we fix this? Well, we are going to start moving the player not using his transform position, but using his velocity. And velocity is available on the rigid body if you find it somewhere right here. I'm not sure where it is. Let's see. Velocity, there you go. We can add velocity in here, angular velocity, the normal velocity. We can change it right here. So let's do that. If we go and you know what, let's add it up here. We'll create a serialized field. This will be a variable of type rigid body 2D, and we'll just call it the player rigid body. Save that. Oh, and one more thing you've noticed, and I forgot to tell you this, it's the way we name our variable. The first word should always have the first letter not capitalized, while all subsequent words will be capitalized. Why is that? Let's take an example from here. You'll notice that player is not capitalized, rigid body is, but the B for the body is not. So if we save that, we'll look in the inspector. You'll notice right here the variable, the way it's written will be player rigid body with rigid body as a single word. If we go back, we make this be capitalized, we save that, we go back in the inspector, you'll notice that now the B is capitalized and it's a separate word. So every time we capitalize one of the words, it becomes separate. But we don't want that. We want it as a single one. You can see the same example in the movement speed. When we go back, there we go. So we've just created a reference to the rigid body on the player, but we haven't added it because you can see right now that the player rigid body, there's just none. So how we do that? We simply click on the rigid body right here and we drag it up. So now you can see, as the name suggests, it's the rigid body on the Doom player. We save that. Back in our game in here, we're going to use, instead of the transform, position, delta, and all of that, I'm just going to comment this out. Later on we'll delete it, but I just want to have this all in front of you so you know the process of what's happening. So now we take the player's rigid body, we access the velocity on it, and it's going to be equal to the movement input times the movement speed. And because we are using the velocity, this will not require any time.delta time. We save that, we go back in here. Let's move this guy up a bit. So now when we run our game, we move around, and if we try to move through the wall, there you go, you can see that we no longer have the jittering because we have the two physics engines working. Well, not the two, one physics engine working on the both colliders because of the rigid body. And finally, we'll just add a couple of more colliders to the background. So I'm going to add another box collider to the I'm going to make this a bit smaller. And now it's never recommended that you add multiple box colliders on the same game object. But for now, we'll make an exception. This will rarely happen. So there you go. Let's add a box collider like that. Let's add another one. And this one will be to the side. So we don't go out. We'll just make it a little bit bigger. And let's add the last box collider, and this one will be the one on the other side. There we go. We save all of that. We run our game. And now we walk down, we can't. We walk to the left, we can't. We walk to the right, we can't. And if we try to move up, we also can't. But there is a slight problem. You can see that we still have space in here to walk up to. So what I'm going to do is I'm going to just make the player's collider a little bit smaller on the top. So let's just make it around here. We can even maybe change this from a capsule to something else. Let's try making it like that. Oops. Where is it? We change the position. So we move it on the X. Yep, there we go. We run our game. And now we can see that we kind of move up. We still have this bit of space. This isn't a huge problem. We can even instead of a capsule, make a box collider or something else. But you can see that it all works all fine and dandy. With that said, Make sure to commit your changes, and in the next video we'll be aiming our gun around using the direction or where our mouse is pointing, because currently you just have this gun, it's not doing much. I'll see you in the next one.